In this example, we're going to take a look at another numerical limit. In this case, we're going to take a look at the limit as x goes to 0 of the function sine x over x. And again, we're going to do that numerically. So going to Desmos to make a table a little bit easier. Here's the function f of x equals sine x over x. And here we can see the value at 0 is undefined because of the division by 0 right here. I can't plug in 0 for x because if I do, then I'll get a division by 0, which is, again, a mathematically meaningless expression. So, okay, so, and also though the limit doesn't care what this value is. It's totally independent of what the limit is. Sometimes it's equal to it and sometimes it's not. So, okay, let's take a look at the right-hand side limit, and here we're going to have some x values that get closer and closer to 0, and then we're going to see we're going to take those values, plug them into f of x here, and here are the corresponding outputs or y values, and we can see that as these x values get closer and closer to 0, staying on the right side, right, they're all greater than 0 but they're getting closer to 0, we see that the f of x values are getting closer and closer to 1. Here, Desmos, the values are so close to 1 that Desmos rounds these to the whole number 1 here. So these aren't identically equal to 1, but they get closer and closer to 1. So it's just showing a 1 because it's rounding things off. So based on the numerical evidence here, we would say that the limit as x goes to 0 from the right is equal to positive 1. Let's check the behavior over on the left. And on the left, we take some values that are getting closer and closer to 0, but all of these are less than 0. They're on the left side on the number line from 0. So again, we're going to take those values, plug them into f, and we can see right here that the corresponding y values or f of x values are getting closer and closer to 1. So again, there's some round off here. So it looks like, based on the numerical evidence, right, that this limit is from the left, as x goes to 0 from the left, is positive 1. So our conclusions here, the limit as x goes to 0 from the left of sine x over x is 1. The limit as x goes to 0 from the right of sine x over x is equal to 1. So we know now that both the one-sided limits exist, right? And they are both equal to 1, so that forces the two-sided limit to be equal to 1 here. And the last question asks about f of 0. In this case, f of 0 just does not exist.